Okay, hi. Today I'm going to be giving you all a quick intro to the Animal Development Lab. So just as a quick reminder, so you should have read the lab packet. So we are working with sea urchins and chickens. So a brief overview about some of the goals that we're trying to do today. During the sea urchin part of the lab, we're trying to be able to identify different or the developmental stages of early embryonic development in deuterostomes. So we'll look at fertilization, and then we'll look at different stages of development. For the chicken development, we have a couple of different stages of eggs, or a couple different ages of eggs. So you'll be cutting a window into the chicken eggs to observe what developmental stage they're in. So just a little PSA before we begin this lab. We always like to have a slide about working with live animals. So just some facts are that animals have been used in science or in research for over 100 years to learn about living things and illnesses or illnesses that affect human beings and other animals. Most of the science or animals that are used in science are bred to be research animals. An estimated 17 to 22 million vertebrate animals are used each year in research, education, and testing. So this is less than 1% of the number that is killed for food. The organisms that we have today are the purple sea urchin, which is Strongylocentris purpuratus, and then our 3 to 4 day chicken eggs, which is the scientific name for that is Gallus gallus. The urchins will not survive the extraction process of their sperm and their egg, so we inject potassium chloride into them, which is acts as a stressor. And so they will release their sperm and their eggs, and then they pretty quickly die. If we were to not extract the sperm and the eggs, the urchins would not survive basically the shipping process. So that's to be said for that. And then per university regulations, we're not allowed to keep the chickens after 7 days. And so they will not be kept either, and they do not they'll survive for like a day after we do the window in it, but they're not going to live to be full chickens. And then one more thing is that animal research is tightly regulated by AICUC, and so you can look into that more if you have any issues or concerns. So to begin the lab, I just want to remind you of some important vocab that you'll need to know. So we're going to be working with deuterostomes today. So a deuterostome we saw last was a character that we used in the last phylogeny lab. And so you should basically know what they are, but we'll just go over it again. So deuterostomes, the mouth forms second and the anus forms first. In protostomes, the mouth forms first and the anus forms second. And so I like to just remember deuterostome because deutero plus stome in Latin means second mouth, and so basically meaning that the mouth forms second. Proto meaning first, so you can also remember that the mouth forms first in protostomes. Okay, besides that, there are two other important vocab words that you need to know, which is it's related to the developmental stages that you're going to be looking at in our sea urchins. And so the first one is a blastula. So you'll actually get to see this. This is a developmental stage of the urchins. And so, of the urchins and also chordate. So all of deuterostomes have this. So basically, after cell division happens so many times, the cells will start to migrate to the edges of the cell, and it'll form this hollow sphere of cells. And that's before gastrulation starts to happen. So it's like that first step. So they all migrate to the outer edges of the cell, and then gastrulation can start to happen, which is that cellular movement that forms the 3 tissue layers and distinct body axes. And so here is a phylogeny of what we of the major phylas that we looked at in the last lab. So you can see here that we are focusing on deuterostomes specifically because they have echinoderms, which is our sea urchin, shares this trait with chordates, which is us. And so it becomes really important because sea urchins have been used to study human development, because the first stages of development are exactly the same. So this is another picture of the gastrulation process in protostomes and deuterostomes. So this first slide up here is our protostome. So protostomes have a spiral cleavage, and when they form when gastrulation happens, the mouth forms first, right? So that's what we went over. In deuterostomes, we have a radial cleavage, and during gastrulation, the anus will actually form first, and the mouth will form second. So the TAs will inject the sea urchins before class for you, but we wanted to show you what sea urchin spawning looks like. And so on the left is a female, and so you can see kind of an orange goo coming out of its anus. So the top of the sea urchin is actually the anus, because they're bottom feeders, so they walk along the bottom and eat things on their mouth. So if there's urchins in the lab, you're more than welcome to ask your TA to look at them if you would like. So on the left is the female. Like I said, orange goo, that's actually eggs that you'll get to observe more up close in lab. And then on the right is our male, and so you can see that it's kind of a white gooey substance. And that's basically it for the sea urchin lab. So you'll go through the process, follow the directions in the lab to observe the sperm and the egg separately, to observe fertilization, and then to observe different developmental stages. Now we're gonna go into cutting the chicken egg window. And so I've made a little video just because I feel like it's a little easier, and just people seem to be more comfortable doing it when they see someone else doing it. So I've made a video that I will play now. Okay, I'm going to show you the tips and tricks to make a window on our chicken egg. The first thing is that the TA should have marked a pencil X on your egg. This is where the egg yolk is going to be. And so that's going to be important later on, but first we'll take the tape that the instructions tell us to. This tape is going to help reduce any cracking of the egg, so it's important to put it on. So we'll put one piece right above the X. Before we cut the window, we have to remove some of the liquid so it doesn't all come out while we're cutting a window. So you're going to take a needle and aspirate about 1 milliliter or 1 cc out of the egg, and I'll show you how to do that here. But first we're going to place another piece of tape over the blunt edge of the egg. And again, that's just going to help with any cracking that may happen. So when we do this, you want to make sure that your needle is directed in a diagonal angle. If you go horizontally into the egg, you will poke the egg yolk, and then it'll get messy, and you won't be able to see the embryo as well. So just remember, keep your needle diagonal as you're drilling your hole in. So the way I like to do it is I'll just put a little bit of pressure, twist it around in that diagonal fashion. So once you puncture the egg, the needle will go down instead of horizontally into the egg. Sometimes it takes a little pressure. And there, I've cracked my way in. Took me a little longer. So now that you're in, you want to keep making sure that your needle is at a diagonal fashion. And then you're going to insert it all the way. Pull a cc of albumin out, the white clear liquid. So it should only look white and clear in the needle. We're going to take about 1 cc out. Put that down. You'll take another piece of tape, place it over the hole that you made the incision mark. Don't need a big piece of tape, but. And so after that, then we can start cutting in our window into our egg. So I use the same technique as I drilled the hole in. So you're gonna take your scissors and you're going to again drill one hole in to start the window. So take one edge of the scissors, same pressure, and then you are into the egg. So then you can just slide the scissors under and start cutting a window. About an inch window will help you see the embryo the best. So I'll just keep cutting. Remember, we just took some liquid out, so there is an air bubble in there. And there's our embryo. So if I tilt it and put it down, you should be able to see the embryo. And here we can see the heartbeat of the chicken. And so this is what you're gonna be looking at in lab. After that, you'll do a drawing, and we're just gonna place a piece of clear tape over that so it doesn't leak out as well. And that's it. Okay. So I hope that helps. I just have some pictures to show you of what it'll look like. So the egg that we just looked at, that's probably like a 3-day-old egg. And so what we saw was the heartbeat. So we could see the heart formation. We also could see all of these little veins here. And I believe the eye starts to form too, but we couldn't really see that. If you get a day or a 4th day egg, you'll be able to see the eyeball and definitely some more distinguishing feet. I'm not distinguishing, but little more shape to the embryo. You might find there might be a day 5 or 6 egg in there, but we also have pictures that you can look at too. And so one thing that is really important to note, and that I want to be verbally spoken, is that you have an introduction due for just the sea urchin part of the lab. So please don't write the introduction on the chicken. It's just for the sea urchins. And so this is copied directly from your handout that you got. And so basically just we're going to be grading you based on what is written here. So we'll go through this together. We will take points off if it's not typed, if it's not double spaced, and if there's not page numbers. So you're also going to be writing your report in the first person active voice. Ensure that your ideas and points that are made in your introduction are made in a clear, organized and clear fashion. Please proofread just once is fine. Have your roommate read it, but we normally find a lot of grammatical errors, so just try to be aware of that. We try not to take a lot off for grammar though. It's just more of a, can we tell you read it kind of thing. And then label your section. So you'll be doing an introduction, and then I believe we're also asking you for a couple of references. And so in setting up your introduction, you basically just need to summarize the what and the why. So what are you doing in that lab, and why are you doing it? Again, just do it on the sea urchin development part. The point of an introduction is to place your research or experiment in the context for the reader. So be thinking about someone that's maybe not in this class and you're writing it for them. Someone who doesn't really know about sea urchins, doesn't know that they're deuterostomes, and that they deuterostomes are also chordates. And so be thinking about that. Again, what is the main idea? The main idea is that we're looking at animal development in deuterostomes. And why is it important? It's important because chordates are also deuterostomes, and we can study early development through this. And then here's some just other questions that your introduction questions that you should include not the questions, but the answers in your introduction. And so these are just meant to kind of help you flow through the introduction. So you could start off with a brief description of what the experiment is about. So why are you performing it? The objectives of the experiment, and then so what is it going to tell you? And then the importance of the experiment. So why should we care about this? And then one more thing, if that doesn't make any sense, think of your introduction and it being more like a funnel. So you're going to start with the broad ideas first, and then you're going to funnel it down. So you're going to lead it into your specific research question and objective. So start with broad ideas, funnel down to specifics. And again, remember, we're all trying to learn what the introduction, how to write an introduction. We're going to try to tell you our tips and tricks. So just do the best that you can and try to answer the questions that we've given you. Some common mistakes that we get all the time in BIOL213, don't use block quotes. So if you want to take something out of the current literature, say you're reading an article, don't take a whole full quote out and just directly stick it into your paper. Please put that quote or whatever you want to say into your own words, and then do the proper in-text citation at the end. When you state the organism's name, also state the scientific name, italicized and in parentheses. You only have to do this once, and then you can refer to its common name, but somewhere in there needs to be the scientific name. I already went over this, but it takes a while to learn how to format a nicely formatted introduction, and it took me my whole undergrad to be able to do it. So it takes time, it takes practice. And then proper APA formatting. So Google, you can do APA formatting on Google or on the library's website, but just double check if your citations, they're coming out of those like auto-generated formatting sites, sorry. Double check if they're coming correctly out of the citation generator. And then again, proofread. And then we have a paper that we're going to put on BBLearn about how we want to see the citations or the references. So we will put that on BBLearn, but it is here down at the bottom if you want to write it. So you're going to have the last name, and then first initials, the date, the title, the article journal name, and then the volume numbers, etc., and the page numbers. So just check that it's going correctly. And that's it. So hope this isn't too long. I will stop. All right, thank you.